Hey there, welcome back to this video 8-3 for AP Calculus, where we're talking about rate in and rate out. This is usually an FRQ question, specifically on the calculator portion of the AP exam. So we're going to look at one question in this video. This is to wrap up the lesson, and we are talking about the number of a particular species of rabbits. They say in hundreds in a wooded area is modeled by a differentiable function r of time t, where r of t is the number of rabbits, or the population of rabbits, in hundreds, and t is the measured in months for 0 to 50. They say if there are 1,500 rabbits in the wooded area at time t equals 0, and the birth rate for the rabbits in the wooded area is modeled by b of t in hundreds of rabbits per month, and the death rate for rabbits in the wooded area is modeled by d of t, hundreds of rabbits per month. They have some questions here. So the first thing that you kind of want to understand is that our total number of rabbits, the population of rabbits, is going to be equal to this function. So r of t equals. Now for these problems, we always want to use our start. What is our start? So I'm starting here. They give us an initial value. They say at time t equals 0. So they give me an initial value, r of 0, and I'm going to go ahead and I'm going to add the integral. They say from 0 to 50, from 0 to, I guess we'll say t, because I can use this to calculate the population of rabbits at any time. But you have a rate coming in. This is your birth rate. So plus b of t, or b of x, I guess I should say here, b of x, minus d, so these are the rabbits that are dying. Sorry. So d of x, dx. Okay, so this is your population function. Okay, so total, and make sure you have this down in your notes from the last one. So total is equal to start, okay, plus the integral of in minus the integral of out. And you can do two separate integrals, or you can do like I did here. I just did one integral from, b of x minus d of x, okay? But this is my total amount. So let's look at some of these questions. A, is the population of rabbits in the wooded area, hey, that's this one, that's RT, here's the rabbits. Is it increasing or decreasing at time t equals 10? Well, what I need is I need to know how is the population changing. So that is a derivative, so r prime. Well, the derivative of r of 0, which is 1,500, that's going to go away. And then I have the derivative of an integral. Well, that cancels, and so I just drop in my function. So this is going to be equal to b of x minus d of x, okay? And so this is how this is how you can change. You can tell if it's changing, right? Analyze the rate of births versus the rate of deaths. So I want r prime of 10. R prime of 10. So I'm going to go to my calculator, and because this is a calculator active problem, I'm going to enter both of these functions into my calculator. And you can see that we have already done this. And so what I'm going to do here is I'm going to say, okay, what is b of 10 minus d of 10? And we can see it is 3. So 3.085. Okay, and again, this is in hundreds. So in hundreds. But the main thing here is that this is greater than 0. That this is positive. Okay, and so we can tell, right? Since this is a positive number, we can tell that the rabbit population is increasing. If it were negative, it would be decreasing. The other way to do this problem is to compare your birth rate and your death rate, b of 10 versus d of 10, and you could see that here if oh wait, maybe this is not right. Oh, it's still positive. But it was a wrong number though. Let's fix that. I forgot the 10. 1.818. The other way to do this is to analyze, okay, what's b of 10? There it is. 3.11, and analyze d of 10, 1.29. And you can say since the birth rate is bigger than the death rate, then the population is increasing. Okay, so that's another way. So we're going to go ahead and say the population is increasing because B of 10 minus D of 10 is greater than 0. Okay, and that's what you need. You need to reference the birth rate and the death rate. You might get away if you identify your function as r prime of t is equal to this using r, because you're clearly showing that what that function's identified as. But you need to reference birth and death rate somewhere in here, right? Okay, and actually, I don't like this. I'm gonna make sure it's capital B and D. Okay, B. To the nearest whole number, what is the population of rabbits in the wooded area at time 50? So R of 50 they want. Well, we start out with 1,500 rabbits at time t equals 0. There's my initial value. And I'm going to integrate from 0 to 50 of the birth of the rabbits minus the death of the rabbits. And we're going to integrate those rates and come up with a new total here. Okay, so again, in your calculator, we can just go down here and we can say, hey, 1,500 plus the integral, int, from 0 to 50 of, and we have b of x minus d of x dx. And they're going to be mean and make me put parentheses around this, around my integrand. Okay, and there we get. There we go. 1,500 or 1,516 equal to 1,516.568 in hundreds. In hundreds. Oh, 100. But I don't like this. I think I made a mistake here. They say, our initial value is 1,500, and then this integral is going to be in hundreds. So I think I need to adjust this. This just needs to be a 15 plus this. 15 hundreds. Okay, so let me adjust this. And there we go. There's going to be, I think, our answer. So it'd be 31.568 rabbits in hundreds. Okay, so that was a little tweak. Yeah, these are going to be in hundreds, so I want to make sure that my initial value is also in hundreds. So 15 in hundreds. Okay, C. To the nearest whole number, determine the maximum and minimum population of rabbits in the wooded area for 0 to 50. Justify your answer. As soon as they say min and max, you need to think candidates test. Candidates test. Candidates test. And who are your candidates? Well, endpoints, and critical values, critical numbers or values. So this is where we make a t-chart, and I'm going to put my endpoints on here. So 0 to 50, these are my t values, and they want the maximum population. That's r of t, okay, r of t. So I have to go ahead and say, okay, when is r prime of t equal to 0? Well, r prime of t, the derivative of this function, is going to be b of x minus d of x. So when does this equal 0? And we can solve this. This is when b of x is actually equal to d of x, or I guess t values here. Okay, so this is pretty easy, especially since we graphed both, right? So t is equal to, let's go ahead and look at this. So when is our birth rate and our death rate equal? These will be critical values. We have 17.282, 282.02, and then looks like we have this value, 42.5. 1068. Okay, so I enter those values over here. Okay, we have these critical values, and then now I'm going to go ahead and I just need to find these values. We already know one of them. We know that at time 0 there's 1,500 rabbits, and we already found R of 50. So this one was I guess maybe this is in hundreds, right? I'll just keep this in hundreds. And this one was 31.568. We already found that. Okay, and then now I just need to know, okay, what's the population of rabbits here and here? And you can kind of get an idea too, right? Isn't our birth rate increasing? And then, the death rate's increasing, okay? And they kind of catch each other here, and then the death rate takes over. So, this might be a maximum population, and then here might be a minimum population depending upon, I don't know. Maybe not. That's not much of a gap. Probably our 0 is our minimum. But anyway, let's go ahead. I'm just going to copy this. So on your TI, you can just go up. You can copy these values. For us, I can just go ahead and kind of change these values here. So this is going to be, what was our first one? It was 17.2802. Okay, and you can see the population there. So 38, I'll make a note here, 38.728. Okay, and then I can do the same thing with 42.51068. Okay, so I'm just entering in these critical values, right? I'm finding the population of this. So we have 30.778. 30.778. Okay, so we'll go back to our work. Usually your table is good enough justification, and then they like to see these critical values. That's usually 1 point acknowledging these critical values, and then we have our population here, and so now we can go ahead and make it a determination. So we can say the minimum population was 1,500 at t equals 0. The maximum population was 38.728 at t equals 17.28202. Okay, for maximum minimum problems, always give the y value. The maximum is this, and then also just for I don't know, safety, include the t value. Okay, so there you go. Minimum population is 1,500 at t equals 0. Maximum population was 38.728 in hundreds. Okay, at t equals 17.282. All right, D, on what intervals 0 to 50 is the population of rabbits in the wooded area increasing? Give a reason for your answer. Well, we want R prime of t, this population, to be increasing, so we want R prime of t to be equal to 0, which means that B of t minus D of t is greater than 0. And so we can go ahead and look at this. And so again, we already know our critical values, right? These two critical values. So we're going to be increasing and positive whenever the birth rate, right, is bigger. That's when the population is going to be increasing. So it looks like from 0 to 17.282, as well as from 42.511 to 50. So it looks like our birth rate comes back up at this last piece here. Okay, so let's go ahead and include that. The population of rabbits is increasing on 0 to 17.282 and 42.511 to 50. And they say, give a reason, because, again, b of x is greater than, or b of t is greater than d of t. All right, so notice in my justifications, I always tend to use the functions they give, b of t and d of t. All right, hey, that is it. That's rate in and rate out. They'll give you a starting value. Your total is always going to be that starting value plus the rate in minus the rate out. Sometimes you might have to make another function here to find the totals. This is beneficial. Always graph your functions first, and then you can quickly enter it into your calculator. Okay. Hopefully you learned a little bit more about the rate in, rate out FRQ question. I'll catch you guys in the next video. See you later.